Orion's Nebula, just as spectacular in binoculars as it is in a telescope or a photograph. And who's that watching me in my backyard tonight? Huh? That'd be Dave Stingy up there. He says, too cold to go outside tonight? No, Dave, this is the best time to go out when it's crystal clear and the stars are beckoning, calling for you to come out in your backyard. Hello, everybody. I am Stargazer Mark, aka Mark Marquette, and so glad that you are here to stay star curious today, as I'm going to get into some backyard basics of stargazing that everybody that is seriously looking at the stars, called amateur astronomers, learned these chops a long time ago. But it's always great to refresh, even for me. And you're going to learn, like I said, some of the basics of the brightness of stars, how amateur astronomers and everybody for that matter gauges and talks about where things are in the sky as a matter of degrees, like why Dave Stange and my friends in Michigan are having some cold weather is because they're at very high latitude, like in 40s or probably 50 up there where you are, Dave. Down here we're at 26-degree latitude, okay? And it makes a big difference in the stars you see, and it all has to do with that protractor that you had in elementary school. So we're going to have, but just 400 years ago, everybody thought that everything went around the Earth in the middle of this celestial globe. The celestial globe's an example just to show you what the star patterns projected on the globe of the night sky. It's not a globe. They're not projected. These are stars across the universe. Some bright, some small, some not so bright, some very large, some very small. And it depends a lot on how close they are to our solar system and our favorite star, Old Sol or Sun. All right. So I'm going to explain a little bit about that. And some great teaching aids for y'all. But first, we want to thank Hyatt Place for their sponsorship of our American Space Museum, particularly our Shuttle Fest that we've conducted there successfully 4 times, and memorabilia shows are now moved there. And I've got my lanyard on here from another sponsor of ours, BRPH, okay, is doing a wonderful party here tonight, a cocktail party, if you will, without cocktail party attire. And we're grateful to Steve Lloyd and BRPH and his whole team for putting a bunch of influencers in our museum here about 6 o'clock. So this is one reason why I'm doing a Stargazer. They're easy for me. Hyatt Place has been a lot of great things for us there. And the 5th floor launch viewing room is the USIAC family viewing room of launches, named after Mark and Tom Usiak, who got their artwork there. There's a nice big picture of it. The other day, going up Route 1, they're at the 405 interchange that goes right into Kennedy Space Center. Hotel rooms, $150 a night, up to, of course, more when depending on what's going on and what season it is. And there's a nice night shot I took of them out there. The Hyatt Place, our sponsor today for Stay Star Curious. And we've got a special birthday today to interrupt Stay Star Curious. Probably one of the few people I'd interrupt a stargazing show about. And that is happy birthday, 76 years old, to Joseph Richard Joe Tanner, born January 21st, 1950 in Danville, Illinois. A veteran of 4 shuttle space flights and 7 spacewalks. He's a Hubble hugger on 2 missions. Many of you might not know that Joe T, as his nickname is, has a twin brother, David, who's a professor at Indiana University. So they're both pretty happy for the national champion Indiana football Hoosiers there. There's Joe waving. I love this. He's kind of waving inside, thumbs up, and then there he is outside on, I think he had 7 spacewalks. One of my very favorite astronaut pictures is Joe T, and this is his elementary school he went back to visit. And Marty, there's your Friday meal: fish sandwich, peas, and peaches, okay? And it looks like he can hardly choke it down, but you know what? everyone in the room is looking at him. I just love that shot, and I showed Joe that, and he gets a big kick out of that. So happy birthday, Joe Tanner! What a great guy. He took this selfie in, let's see, when was that selfie taken? That was one of the selfies of the year, um, and he is going to be inducted into the Astronaut Scholarship Foundation U.S. Astronaut Hall of Fame this May. All right, along with his other Hubble hugger and Tom Akers, I mean. And so that'll be a cool induction at the, of course, at the Kennedy Space Center. They do it upright under the Saturn V building for a big dinner, and then ceremony is in the public at the Atlantis. The Atlantis exhibit at Kennedy Space Center. They have an induction on that Saturday for the public to see that morning. We've been to it several times, haven't we, Marty? Very enjoyable there. Say hi to my buddy Marty Winkle there, everybody. So, Joe Tanner, happy birthday to you. There he is with Mitch Rothman at Shuttlefest. Joe T was a big hit at Shuttlefest. Thank you, Mikey Haddad, for bringing this wonderful man to our museum. He really digs us and gets us, and we said yesterday we had a nice experience with him out in the parking lot, meeting him, Marty and I did. So, let's see, STS 66, 82, 97, and 115. He joined the University of Colorado Boulder's Aerospace Engineering Science Department as a senior instructor, has done that, but he pretty much lives and does what he wants to do in West Colorado. So happy birthday, Joe T, on our special Stargazer episode of Stay Curious. So the moon is, I didn't even look it up today. I think it's going to say it's 3 days old. I saw it last night, thin crescent. Did you see it, Marty?
No.
And that's why I wanted to talk about astronomy, because the moon pulls all eyes up. I don't care if you're getting in your car, you look up, there's the moon, you see it for a couple seconds, and you're back in. So then you forget all about it. So I wanted to see what my app says. And let me go. I use Phases of the Moon is an app on my Android. Okay, there it is, Phases of the Moon. I can show you what that looks like for those of you wondering. There's the small image there. So we're at 2.89 days, and it shows it to you like that. Okay, you can see the whole month of moons by going up to the date there, and then you get the whole moon thing there. And today it is 3 days old. Okay. 9% of it is exposed, so it's about like the 3-day-old one we have right there. So it'll be beautiful tonight. I'll tell you when it's near Saturn, probably in about 3 or 4 days. It's in Aquarius, moving into Pisces. It rose at 9:07 this morning. It's going to set at 8:47. All right. So to talk like an amateur astronomer is to say the moon's 3 days old. Let's go out and do a little bit of stargazing tonight, Bob. And Bob says, yeah, great. We're going to see some galaxies and nebula. But if you said to Bob, hey, the moon's 13 days old, let's go stargazing tonight, my friend Bob's going to say, heck no, we're not going to see anything. The moonlight's going to outshine everything. So that's what it's all about. Of talking like an amateur astronomer, is the days of the moon dictate when the moonshine is going to keep you indoors, because you just can't see things with all that extra light. And the moon goes from about, we're going to call it first magnitude tonight, to minus 14 magnitude during full phase. And I'll tell you all about that, what that means here in just a second. Some beautiful things you're going to see in the sky, particularly the transition between winter and summer and winter and spring. You see a lot of phenomenon. This is what's called an anti-crepuscular ray that is over the Atlantic Ocean. A cloud in the west has projected itself across the entire dome of the sky, and the light shining off of the effect there makes it a cool effect. This is a All these are photographs I've taken, unless I note otherwise. Sky maps. You probably got one in something around your house, like the old Encyclopedia Britannica that's in the room you never use on the bookshelf. But it's a free skymaps.com. You can go there, download the monthly map. What's happening in astronomy right now, Marty, is everybody's going to digital cameras that download pictures on top of pictures, and you can see the Orion Nebula, the Pleiades, and so forth from the comfort of your home projected onto your favorite TV screen. All right. And that's what the thing is on the left right there. C-Star. The C-Star 50. It's like a 50 millimeter binocular. All right. And every amateur astronomer has great telescopes, and then usually they buy something like this that's not a toy, just kind of a convenience. But it's revolutionizing astronomy for sure. Here is our sky map of the month of July, towards the end of July here. Let me put my spectacles on. For today's date, Mercury is at superior conjunction with the sun and not visible, all right? The 23rd, the moon will be near Saturn, okay? So that will be Friday evening, the moon will be near Saturn. First quarter moon is next on the 26th, okay, which is Monday. Now, as you see, it gives you highlights on the left, and you see there's a band going across there. That's the Milky Way, all right? But Mark, I thought the Milky Way, you're saying, is a summer constellation or summer phenomenon, not constellation. No, it's fainter in the winter, but it's definitely there, and it's over dramatized here. That doesn't. They should have it a lot fainter. But particularly Cassiopeia, the W constellation right above my head over there, it has some texture of the Milky Way. You can see this is a spiral arm called the Perseus arm of our galaxy, and our galaxy is like a pinwheel, and this is stretching across our night sky. All right, Jupiter on the upper left here is in the constellation Gemini, the twins. Jupiter's right over here. I know you can't see that. I'm not going to pretend to that. But rising in the east, high up in the sky, is Jupiter. Jupiter, you can see easily about probably 20 degrees above the horizon by 7 o'clock at night. And you're gonna understand more about when I say 20 degrees above the horizon. That would actually be my hand spread about like this from my thumb to my finger right here. It's about 20 degrees of sky. And we're going to go over that here in just a second. Great Pegasus squares up there. Orion is rising, and that brings up the bright star Sirius and Canopus. There's a real bright star Capella in the sky. So, great time to stargaze. And, of course, one of the most recognizable constellations in the sky is the stars of Orion. Okay, and this is Orion in your backyard. Is that the good one? Yeah. This is about how you would see it. There one other shot in there. And then I'm going to show you okay, there's a fancier picture of it. This would be Orion in your backyard. Third magnitude stars are about as faint as you're going to see. And I'm going to explain magnitude. The belt of Orion goes across the center frame here. The two stars at the top are his shoulders. The two stars at the bottom are his kneecaps. All right. And in between, dangling from the belt, is the sword of Orion, where inside of the sword, right here, that's not a star, the middle one. No, that is the great nebula of Orion. All right. Now, the top two star left and the star right here, Betelgeuse and not Sirius, Rigel, are first magnitude stars. The belt stars are all second magnitude stars, along with the other shoulder and knee. All right. And the ones that are hanging down are about third magnitude stars. Now, this is a time exposure of maybe 30 seconds, so you see a lot of other fainter stars in the background, but you would not see those on the night. And to put a little cross filter on my astrophotography gives it a little bit of a snap. Okay, can be over dramatized or not, but this emphasizes the beautiful outline of Orion the Hunter. And the stars have Arabic names. The one in the upper left, Betelgeuse, that translates to armpit of the giant. Okay. Rigel literally trans in Arabic into knee. All right. So on and so on. What I want to emphasize is when you go out in your backyard and look at the stars, you're looking in a time machine. All right. And that's something I know Marty says that he has a hard time seeing the constellations, and there's a lot of weird ones that don't look like anything like they're supposed to. But Orion, I see the figure of a man very easily, and hope you do too, Marty, with the shoulders and the knees, and his waist has got the belt in the middle. The rest is you figure it out. The head's really not there at the top. You figure out what you want for a head, and he's shaking his head.
I don't see any constellations.
Okay.
I see the Big Dipper. That's about it.
That's why we have engineers and artists, two different people there for sure. Well, Marty, the one star Betelgeuse I talked about is 310 light years away. That's pretty doggone close, okay? But Saf at the bottom is 1,300 light years away, okay? And if we switch places with those two, all right, and Saf was only 310 light years away, you could read a paper at night with it. It would be so bright. Bellatrix, again, another very close star, but not too luminous. It's not putting out a lot of energy, all right? The Great Nebula of Orion, when you're seeing it with your naked eye, you're seeing 1,300 light years away. You're seeing something that left in the year, if this is 2020, 2000, it left in 1900 and what? In 1,300 years ago. Rigel's 910 years. So yes, these stars might not even be there. All right, blew up, and we wouldn't know for 910 years if Rigel blew up today. So we're looking through a time machine. And I love the belt stars. Alnitak, Alnilam, and Mintaka are the names of them. There's another crosshair with a little telephoto lens on a tripod that was guided a little bit to show you the Great Nebula of Orion in the belt of Orion's stars, and its weapon dangling down. Well, of course, Saturn is up in the sky, and the edge on it looks like a butterscotch star all by itself in the southern part of our sky, southeast or southwest. I mean, this is what it would look like tonight in my telescope as the rings are starting to open up a little bit more after going edge on. You need a telescope to see them, as you do need to see the bands and red spot of Jupiter. Another photo I took of Jupiter a while back, and there's a lot of details that the human eye sees that the camera can't capture. So Jupiter's blazing bright, the brightest thing in the sky. Even the brightest star Sirius that's rising is brighter than it. So how do you identify things in the sky? Okay, first you say, is it really big, to yourself? You go, well, are your eyes burning? On the left, if your eyes are burning, you're looking at the sun or the moon. Ha, ha, ha. Sober up, please. Is it moving? If it's moving quickly, it would be a meteor. Okay, if it just shoots across the sky. All right, you have a meteor that can be a bolide or a fireball. So a streak in the sky, as we go down to the left of this chain here, down to bolide or fireball. That's what we have here, is a bolide, where a meteor that enters the atmosphere, the streak of it burning up in the atmosphere, and then it blows up, all right, as all that compression shatters this meteorite. The meteor is a meteoroid as it travels through space. It's a meteorite going, let me reset. Meteoroid is when it's traveling as a rock for maybe millions of years. Maybe it's the size of a pebble. Maybe it's the size of my fist, okay? But when it goes through the Earth's atmosphere, it's going to heat up like your hands getting warm from friction. And it's a quick burst of light, and then it's gone, all right? That's a meteor in the sky. But if it lands or blows up and pieces fall off of it and lands on the ground, that is a meteorite that you see, on the ground. And that is Orion there that it's going through, all right? See the stars belt of Orion? And it's going right between Saf, the right knee, and the sword of Orion. All right, if it is not a meteor and it's moving quickly, is it an aircraft? Is it a international space station? Is it a artificial satellite? All right. Also on the right-hand side, that's a little misnomer. Is it moving, meaning it's moved from one place to the other in the sky? It could be a star, a comet, or a planet. All right. Planets generally are bright by reflected light. They're not a source of light. That's why they don't twinkle. They'll twinkle some, but not as violently as a star will twinkle in the atmosphere. But we want to pinpoint: is it an aircraft? Is it a satellite? Could it be the International Space Station? Or is it a UFO? All right. Well, here's a picture of the winter Milky Way in Cassiopeia. She's a W or M on its side. And you see at the top, you see streaks going through there that are blinking. This is a time exposure. Those are airplanes because they're lights of an airplane blink. You have red, white, and green lights on an airplane, and they blink. I don't think the white one does, but the red one does. And that signifies that it's not a satellite. If it would just be streaking across the sky and no blinking, I don't have anything in there, that's a satellite. Is the International Space Station. If it's really bright and gets brighter as it gets overhead and then fainter, that is probably the International Space Station, and there is an application for that for your smartphone. There are satellites crossing the field of view on an amateur astronomer's photograph of the Great Nebula of Hercules, M13. And these are Starlink satellites, and maybe a couple of them aren't, but they're plentiful. There's over 6,000 of them orbiting the Earth, and they when they catch sunlight reflected off of their solar panels, can mess up an amateur astronomer's photo like this, probably a couple hour long exposure here. The concept of a star's brightness is called magnitude. It is a logarithmic scale. That first magnitude is 2.5 times brighter than second magnitude. First magnitude is 6.25 times brighter than third magnitude, all the way down to that bright star Betelgeuse. The armpit is 100 times brighter than the faintest stars you could see at a Colorado Rocky Mountain away from light situation there, because 6 magnitude is about as faint as the human eye sees. An arbitrary logarithmic scale. I forget who invented this crazy scale, but it gets ingrained in your mind. Okay, so on any given, there's only one star on the average night. Okay, in the night sky. Okay, you might see one star at -1 magnitude. That would be Sirius. Okay, there might be 3 stars that are 0 magnitude, and then you go to plus. All right, that logarithmic scale includes 0, so you have 0 and then minus numbers. All right, the full moon is minus, I said 14. They're saying minus 12.5. I'll go for that. The sun is minus 26 magnitude. All right, but tonight I'll be lucky to see 8 stars of first magnitude and another 35 stars of second, and maybe 120 stars I could count at third magnitude. So 120 and 30 something is 156, plus 8, 144. There's about 145 stars that you can see from your light polluted background skies, okay, wherever you're at. Of course, if you get away from the lights, you can see down to these other level of stars on a clear night, 4th, 5th, and 6th. See, there's 300, over almost 400 stars of 4th magnitude on any given night, and 1,100 stars. So it's a total of about 6,000 stars are visible to the human eye if you could see all the way down to 6th magnitude. with the naked eye. Now, when you add a telescope or binoculars, you see the fainter stars in the 7th and 8th and 9th magnitude. And there we go, another scale of magnitude, okay? They call this apparent magnitude, okay? The limit of the Hubble telescope is about 30 magnitude. Binocular limit is 10. So you can see faint stars, 2.5, 2 point, about a lot fainter than with the naked eye with the binoculars. All right. Here you got Venus is the brightest at -4 point. All right, when it's at its brightest. They don't have Jupiter in there. Jupiter's almost second -2 magnitude. So you have Jupiter, Venus, the moon, and the sun are the brightest objects. Don't know why they don't have Jupiter in there. Again, to emphasize the scale in a different way, Hubble, we're seeing the naked eye limit is 6 magnitude. And then the brighter ones are in the negative magnitude. Let's talk about how high things are in the sky. Okay, if the International Space Station is going overhead at 66 degrees, all right, how do I interpret that in my head when it says International Space Station tonight will be coming overhead at 72 degrees? That means it's going to be a favorable, all right, but it may start out at 10 degrees above the horizon, and then at maximum height is at 66, and when it disappears, it's at 31 degrees. And when it disappears, it's going into the shadow of the Earth. There's no more sunlight hitting the solar panels. Instant night. So this stems from the protractor. Directly overhead's 90 degrees. All right. So 66 degrees to the left on there. You see that this is about very high up in the sky. All right. 10 degrees above the sky is just above the tree line. All right. But if you are where your latitude and where you get your weather by how warm it is by the tilt of the Earth's axis or cold is determined by Polaris, the North Star. And like I said, is above the horizon here about 26 degrees. And up in, let's say, Cleveland, Ohio, it's about 42 degrees above the horizon. So we see a lot further south down here in the sky and less of the northern circumpolar stars. This would be a case where the moonrise over the Gemini Monument at our Gemini Space Walk of Fame, it's about 10 degrees above the horizon right there. All right. Now, how do I know it's about 10 degrees? I'll tell you here in a second. Pleiades, here you got Orion outlined, a suburban situation going above the horizon. You see the Pleiades. Pleiades are right over there. Taurus the Bull is about 45 degrees above the horizon. The Pleiades star cluster up above is, say, about 70 degrees above the horizon because of this protractor here. Oh, somebody's calling me here. I'm not going to answer that right now. So, an easy way to judge distance is not distance, but the distance, distance across the sky is your hands. Okay. You outstretch your arm, your little finger is 1 degree across. You can always cover up the moon with your little finger and your outstretched hand. Scout's honor, 3 fingers, is 5 degrees across. Your fist is 10, and this is about 15. I said it was more like 20. Depends on how big your hand is on there and how much you stretch it out. Oh, I'm going from the thumb. Yeah, your 4 fingers there like that. Rock and roll is 15 degrees, and to the thumb makes it 20 degrees. And there's the Big Dipper ratio. Marty knows the Big Dipper, the 2 pointer stars at the end that point to Dubhe and Merak, that point to Polaris, are 5 degrees across. The top of the bowl of Dipper is 10 degrees across, and so on and so on. And once again, we've got that chart to go through there. Now, this is a series of satellites going overhead. Actually, this is the International Space Station, okay? being followed by the shuttle, and 2 other satellites happen to be in the area there. That's a time exposure. To capture an image like this is luck. The photographer turned his camera on. I can tell, but not very long, maybe 2 minutes at the most. If it was guided, it is still not very long. You got above my head the Pleiades. This is the V of Taurus the Bull, and Orion overhead. But that's something lucky that we all hope to get sometime, a shot like that. Well, let's look at some other pretty things in the sky. Enough technical stuff for y'all as we go out here on this Stay Star Curious episode. Marty, got any questions over there? Or anybody snoring, mesmerized, looking for their binoculars?
Well, I can't tell if they're snoring, but there's no questions.
Okay, we're glad everybody's watching today. This is another dramatic effect in the sky. This is, man, it's so cool to see this when the sun sets and these clouds on the horizon, and that's about 5 degrees above the horizon, the top of that cumulus cloud, is projecting its shadow across the sky in a crepuscular ray, we call it. There are some anti-crepuscular rays. You see where the dark bands are going over the white in there on Cocoa Beach. Another phenomenon to look for as you're outside and sunset is, talk about it many times, the belt of Venus. The belt of Venus is the pinkish area in this photograph. What's happening on the bottom, that's the shadow of the Earth. Just like you go outside and project a shadow, Marty, on the sidewalk, that's the shadow of the Earth projected in the sky, and then it disappears as the darkness, is there, and you don't see the shadow, and you can see everything through the shadow. It doesn't block things out unless the full moon goes in front of it, all right? It's just like you see the sidewalk through your shadow, all right? And the belt above it is a phenomenon of the atmosphere scattering of light, a lot of it, some of it pollution. And since antiquity, Roman days, they call it the belt of Venus, as in the brassiere of the goddess Venus, all right, girdling the whole earth as a Mother Earth type of imagery. Something that you see from time to time in the transition of the seasons, particularly fall to winter and winter to spring, are these rings around the sun and the cloud and the moon. It is always 22.5 degrees radius, so it's 45 degrees across, all right? 45 degrees of sky there, and I could put my little finger over that full moon, and doesn't always have to be full, and blot it out with my pinky there. A lot of legends over this. You would count the number of stars you could see inside this ring, and that'd be how many days until maybe it rained, if it was a drought time or something major was going to happen, the ancients would think, because they didn't know the phenomenon was causing this. And that phenomenon is ice crystals. And they're just not any ice crystals. They're ice crystals that are rectangular in shape with a hexagonal edge to them, and when moonlight or sunlight hits them, they can create this perfect ring around the moon. Spectacular to see and fun to photograph. So thank you all for watching as we're looking at this beautiful shot of Cape Kennedy and Cape Canaveral in the back there. On a surreal type of sunset evening. The sun's behind me here as I'm photographing out at Spaceview Park. The belt of Orion up there, you can see the red of Betelgeuse there. So thank you for watching, Dave Stange and Ophelia and RG Jubilee, Jim McDade. Hope you enjoyed this. Steve Jokums, Mostly Park, Doug Forrest, Tom Busiak, Dean Babcock, Gary Gerald, Michael Bruno, Kate 3.14, and Cliff Watson down in Pomona, Australia, who he's saying, Mark, all of your constellation Orion pictures are upside down, because they are upside down under there with you, Cliffy. So, yeah, thank you all for a lot of cold weather people up there, okay? Jim McDade said he saw Aurora. you want to keep up with the latest of things in the sky, spaceweather.com is my main resource. I meant to do a slide of it, but didn't. So, but spaceweather.com will publish your photos of the aurora or anything that you see in the sky of interest, maybe crepuscular rays. I've done that a few times. So, thank you all for staying star curious with me, Mark Marquette, today. Tomorrow will be I think tomorrow we're going to have to do a reprise show, Marty, because I've got to go out to the Apollo 1 movie documentary premiere at the Space Center. So did we talk about that?
No.
All right, we'll talk about it later. As we've got a lot on our plate here today, grateful that the BRPH folks are hosting an event here. So I'm going to segue out of here and go in and do a little press in the flesh with the community leaders and a lot of influencers in our space community so that they can see for their own selves, like what you know, how fabulous the American Space Museum is. So until tomorrow, I'm Mark Marquette saying we can't wait to see you again to bridge the space between us under the stars, Marty. Let me get outside and get some star shine. Thank you.